For sure, AI is really useful for predictive. Some of the, say the older AI, or, the machine learning, more statistical treatments are really good for predictive analytics. Some of the new generative AI are good for predictive analytics. And then AI is uniquely, the new AI, the generative AIs are uniquely powerful for prescriptive analytics, where you're actually creating guidance and playbooks for people on like how to solve a given problem. So this was an example of analytics AI finding the root cause of a bottleneck, being able to resolve many of the bottlenecks, and we unlocked enough speed that they were able to save $7 million off of this new CapEx purchasing they were going to do, right? Reduce from 21 to 14 million and fulfill the customer's orders with confidence. So that's the delta. When you have tons of rich information, you don't need much training for these AIs to find the right answer. When you have little information, you need more training and pattern matching, and it could still be wrong, but
welcome to the AI in Manufacturing podcast here on Industry4.tv. I'm your host, Kudzai Manditereza, and today we'll discuss using AI and digital twins to enhance workflow efficiency in manufacturing. And to help us unpack this interesting topic, I'm joined by Andrew Scheuermann. I hope I'm pronouncing your name correctly, Andrew, who is the CEO of ArchFX. So, Andrew, it's so great to have you on the show. Welcome.
It's great to be here. You pronounced it perfectly. Guess it makes sense because you're in Munich, right?
Oh, yeah. Cool stuff. Yeah, so, I mean, to kind of like kick things off here, could you give us an introduction about yourself first and also about ArchFX?
Yeah, absolutely. So I'm Andrew. I'm the CEO of ArchFX. We're a data and AI company for manufacturing, originally focused on electronics manufacturing, but used across discrete semiconductor, electronics, plastics, these sorts of areas. At a really high level, we're going to get into it, but we use data from machines and systems to help predict and guide actions, we like to say intelligent actions in the factory. And my own background before Arch was in semiconductor machines. So I built like X-ray inspection deposition machines. For folks familiar with semiconductor, I built like atomic layer deposition, chemical vapor deposition machines. And Arch's other co-founder, Tim Burke, was in like large-scale data analysis, did his PhD in Markov chains. So we were like a manufacturing machines guy and a data analytics person came together to make a company that focuses on how to use the data to guide actions.
Oh, that's super interesting to learn that you actually have a background in building the machines for like the manufacturing machines, because in many cases you kind of like have, some sort of like people coming from the IT side of the data side of it with no manufacturing background as it is. So I think that's really interesting to learn that you have a deep understanding of exactly what goes on in the manufacturing environment. So, I mean, as you kind of like mentioned that you have a focus on discrete manufacturing. So in your view, what are the most significant opportunities that AI presents for discrete manufacturers today?
It's significant, the opportunity. I think people still haven't realized, like, AI is a buzzword, it's a hype word, and everybody kind of knows it's like can do stuff with data. And a lot of people are starting to play with ChatGPT more, and they're like, wow, it knows so much. But the opportunity is significant for combining all the data of the factory with the tacit knowledge, the expert knowledge of the factory to do guidance. I like to break it down. One of the frameworks that our industry's used for a long time, when you think about analytics, for example, was, do your analytics just describe what's happening? Can they diagnose it? Can you predict? Can you prescript, right? Prescriptive. And I think AI helps at like every piece of this journey. AI is making it easier to get data really efficiently and map it together. It's making it far easier to do the diagnosing or the root cause. There's some amazing AI use cases to like automatically figure out what's in your data and like, why did a problem happen? AI can look through all that information. For sure, AI is really useful for predictive. Some of the, say the older AI, or, the machine learning, more statistical treatments are really good for predictive analytics. Some of the new generative AI are good for predictive analytics. And then AI is uniquely, the new AI, the generative AIs are uniquely powerful for prescriptive analytics, where you're actually creating guidance and playbooks for people on like how to solve a given problem. So I would say those at a high level, and yeah, really excited to get into specific ones, but maybe if I can share, high level framework one, and then one very specific use case. One of the generative AI applications that Arch has in production and beta with our top customers is an automatic understanding of the root cause for downtime. So for a long time, there have been a lot of systems, MESs have had them, OEE tools, analytics tools have had them, that let you, manually label why you had a downtime. 4 M's plus E, right? Machine, method, man, materials, environment. So you'd say, hey, I have a downtime. Why? Oh, my machine is down and it's, the robot nozzle is broken or a motor's broken. Okay. Oh, my line is down. Why? I'm out of material. Which material? Material type 2, resistors or pellets, whatever. And so you could manually click that. And if you took all the time to click it, at the end of the day, you'd have a nice report of why your line was down. But that took a lot of time to do. People would skip it, it's error prone. And if you do it, it's competing with the very little time operators have to fix the line itself. So anyways, this is a very specific and powerful AI application we've built, which can leverage notes and comments that operators are making, as well as machine data, to automatically figure out it's down because you're out of material 2, or it's down because this part of the machine is broken, right?
I mean, kind of like as you explain it, like the opportunities are clear, the use cases also, they're very clear. I mean, this kind of like really gets, talked about almost everywhere, predictive maintenance, things like that. But I was kind of recently, as I was kind of like preparing for this season of the podcast, I went through some reports from analyst firms, just kind of like get a sense of who's implementing AI among manufacturers. And one of the things that I sort of like realized was that there's a lot of sort of like manufacturing leaders who are reporting that they are in a way stuck, or they're not really realizing the full value of AI, as it were. Right. So maybe in your experience, what would you say are kind of like the primary challenges that you believe are sort of like hampering, the progress of AI or the realization of value from AI implementations?
Oh, for sure. I mean, first, to answer this question, like a lot of when you do those surveys, so many manufacturers say, yeah, we're using AI in the factory. And they often mean one of two things. They had an older project that was collecting a little bit of data, maybe doing a very first machine learning. That's great. But that's not the new generative AI. They're still, first use case. But the other thing a lot of people say is like, oh, they tried out a chat bot, and maybe they gave the chatbot an equipment manual or something, right?
Yeah.
But people aren't really using it. They're not really getting it. There's so much more than just a chatbot when you integrate it to the data. So this is your question, Kudzai, is really like, what is holding people back from realizing it? It really has to do with digital twin, like building this digital twin, this model of the factory where all of the rich data is properly linked together. Like, let's be honest about it. There is a ton of data in factories. Like, there's other spaces out there where there's less data. AI is still good, but like factories is a unique space. There is tremendous amount of data. Like, every single piece of equipment has a tremendous amount of data. Every existing system in the factory, the MES, the CMMS, the PLM, has a tremendous amount of data. Every person in the factory has a ton of data in their head that's not written down everywhere, right? There is all this data, and it is complicated. And in the past, it's been prohibitively expensive. But it's a lot more cost effective now to get that together. If you have the data properly linked, AI can do amazing things with that. But when the data is messy, is in different places, is not properly linked, like, you can kind of use AI to get there, but there's not a magic AI that will just like collect it all and organize it for you. So that is really the first stumbling block. And if I could add one beneath that, one of the stumbling blocks has been that every organization has been trying to kind of go at this alone, pick whatever tool and try to figure out their schemas all by themselves. And some of them have done a good job because they have been able to invest significantly in in-house teams, 20, 30 person teams that have all these different AI use cases available to them. But many companies just couldn't do that. Or even if they had a team, they got off. It's not easy to build, these whole data collection and digital twin type systems. And every company's kind of been trying to do that alone in the past. That's a challenge.
Yeah, absolutely. I mean, you kind of like raised quite an interesting term there, digital twins, and I want us to kind of like go more into detail on exactly how you sort of like, you believe digital twins are crucial in the enablement of AI. But first of all, could you, kind of like give us a definition of what, in your view, is a digital twin? As you may know, there's kind of like many ways that people really define digital twins. So kind of like to sort of set the framework for us here. Could you kind of like give us a general description of what is a digital twin to you, and then maybe expand more on how kind of like that links with the AI?
Yeah. A digital twin for me is a data model of the factory that is linked to the real data flowing from it. So for me, it's not just like a CAD, like a visual model. That could be a component of it, but it's not just a CAD model. It's not like a simulation only of the factory. Simulations play a big role. For me, digital twin is like here's my factory. I want a digital twin of the factory. What does that mean? It means like in software, I have a model of what's happening. Let's say I have 20 machines, I have 5 lines, I have these people and products, products, and processes. Those are modeled in my software, and it's connected to the real sources of data in the factory. So here's the real factory, here's the digital twin of the factory with the same model and the data flowing through it.
Oh, interesting. So kind of like, if I understand it correctly, so for you really is that real-time view, right? That synchronization between what you see on the digital side of things and what's happening. It has not much to do really with the history or the simulation, but just that real-time capture, that stream of information coming from the sensors. Is that correct?
If you have a digital, like a real-time digital twin, should you have a historical copy? Like, yeah, don't throw it away for sure, right? So definitely for me, the historical data is extremely important. And I know that at Arch, when we work with customers, we encourage them to not throw any data away anymore. The cost of compute is important. It's really important to optimize, but like the cost of data just keeps dropping. And even though there's a lot of data in the factory, I think this is one thing people misunderstand. We talked about how much data there is in the factory, and so people jump to, oh, I think the total bill to store it and the latency is going to be some huge problem. But it's like, no. Actually, there's lots of little pipes, and the total data volume is like, let's say it's in the gigabytes or hundreds of gig. Like that's nothing. Okay, you start adding tons of pictures and videos. Okay, you're going to get into the terabytes and et cetera. But still, this is nothing compared to the volumes of data things like social networks deal with. It's not that it's so much data to store at the end of the day. It's so much data to go get from all these like little pipes and manage. That's what's tough about it. So back to the digital twin, I know the people, processes, and products in the factory. They're connected to all the little pipes of data, real data. And then given I have this, for sure, now I, should have good historical storage of it. I should optimize that cost. I should have all kinds of dashboards and applications on top, right? But the digital twin for me is the model of the factory connected to the data.
Okay, so maybe just kind of like talk more about now this idea of a model, because I suppose this is kind of like what really enables, the AI use cases, the idea of creating a model. What is it about kind of like that model, that enrichment of the data? Can you kind of speak to us about what do you mean by a model, right? Maybe that's a good way to sort of like put it and kind of like tie that into how it enables AI.
So like let's take, instead of a whole factory, let's take a single machine, right? So we work in electronics where you have these pick and place machines, for example. So there's like robots that are you picture your green circuit board that's inside your phone. It's got chips on it. That's picking up a chip and putting it down, right? So what would like the bare simple model be? Like in software, you would say, I have a machine and the machine does a placement operation. So like that's all I define in software. A machine exists. Maybe I have 3 of them: machine 1, machine 2, machine 3 in my software, and they do a placement. And I'm going to connect one piece of data, which is every time I do a placement, I just count, 1, 2, 3. Okay, that is a digital twin of that machine. It's not a very sophisticated one, but it is one. Okay, how about I go further than that? Like when I place, I have a pressure value. I have a coordinates. Maybe I get a picture of it. Maybe there's all kinds of error codes. Maybe there's states. Maybe this machine has multiple robotic arms. Maybe it has a sensor telling me about the material feed in. So now I have 10 attributes of my machine that are also connected to sensor data and values. Okay, now I have a better model of my machine. So I've got my factory's made of 3 of these robot placers, and each robot placer has 10 attributes, right? So yeah, anyways, what I mean by the model is in software, the object, right, defined and connected to the data, and then a good or a more complex or complete digital twin means how much of the physical operation of the machine can be captured into that. So my own background building semiconductor equipment, I was more lab grade equipment. So I was usually using like National Instruments LabVIEW or test stand on the test machines, these kinds of things. People are familiar with these kinds of things. But you're building your machine software, and you're like, what are the pieces of my machine? Do I have a sensor associated with each one? Oh, I have temperature. Do I just have one temperature sensor for the whole machine? Do I have 10 at different points? And so if those sensors exist and they're critical to how the machine operates, ideally you are getting more and more of that into your software model, your digital twin of the machine, so that it more and more represents everything that is known in the real world about the machine. This again is what enables AI. So we have this simple picture we show that it can't pull up here, but maybe we can picture it in our minds. It's like if you as a person, if like we were in a factory today and we were looking out, you would see everything, your eyes, your ears, like you would see the machine, you'd see the lights flashing, you'd see all the operation happening, right? That's your head's model of your mind model of the machine. It's pretty rich. You can see everything. But for a lot of people's data models, they've just got the machine and maybe just the like that, there's a light on top. Picture that light that's going like green, yellow, red, right? And that's the only thing that they have connected yet today. So their digital twin of the machine is just a machine exists and it's green or it's red. And that's the only thing they know. And that's the only thing that AI can know, right? Whatever's in your digital twin, that's what you can feed to these new AIs. Hey, the AI just, it accepts data. So say, hey, give me data. Here's what I have. I have 3 machines in a factory and I can tell you if they're green or red. And the AI is like, well, I'm extremely intelligent, but I can't tell you very much about it. I can tell you when they're green or they're red. On the other hand, if you took the time and you have a great digital twin, the AI can go, I can tell you exactly how much time they're spending, up and down in different error states. Well, I also have the error manual. I know the errors in the error manual. I can tell you what the error codes mean. Well, I have the pressure values. I could help you predict when that pressure is going to go off and you're going to have a maintenance. And then when you have a maintenance, I can tell you how to fix it because I know why it happened, and I had the manual that tells me what to do about it. So suddenly you start getting these rich outcomes when you've linked more of that data together.
That's super interesting. So yeah, it kind of like really sounds like this is really more about really digitalizing sort of like every piece of equipment on the shop floor. And I imagine that also involves if you've got sort of like situations where a piece of equipment may not already have some mechanism of sort of like generating this vibration data, that would involve kind of like retrofitting some sensors into this to kind of like create that model that you want to sort of like portray, right?
Yeah, we like thinking about, I've said this, kind of our 3 Ps: people, processes, and products, right? So on the process side, you sometimes have advanced machines and maybe an MES and SCADA systems and others that have gotten part of the way there at digitizing everything. So then it's just, okay, go get it. And you bring up the point inside of processes that there can be a machine without sensors, right? An old machine, or maybe there's a part of the machine's operation, like a motor that can fail and there's no vibration sensor on it. And those are exactly opportunities, like you said, where, okay, maybe we should invest in new sensors, a retrofit sensor, right? So you can retrofit with vibration and temperature. You can retrofit, like a lot of machines have PLCs inside. You guys do this extremely well at HiveMQ. There's PLCs inside but they might not be well instrumented to a SCADA or a control system. But there do exist driver libraries to get that PLC data out, right? And so, yeah, there's a whole class of retrofit technology that's really valuable. And not to go too off track, but to the products and the people access as well is kind of a similar idea. And this is where, like, if we go to the people and the products, factories are bringing in smart camera systems to be able to see what's going on. And also something we do at Arch as well is like a mobile application where people can talk and say what they're seeing or take a picture as well, right? So getting people's spoken observations about what they're seeing, and whether it's phones or fixed cameras on the line or above, those are also new data sources. So you've got machines that are rich with sensor data, you've got retrofit machines, you've got camera systems and phones, and these are the data sources that, again, if they're not put together in a digital twin, man, what a mess. You might have some disparate use cases here and there, but if you can start concentrating them and putting them together into these data models, then you can really harvest more of the value of what AI can bring.
Awesome stuff. Awesome. So, we may have sort of like manufacturing leaders, that are listening to kind of like the conversation now and say, okay, that sounds great, but how do I actually approach this strategically? Do you have kind of like some essential steps how they could kind of like think about building a digital twin as a foundation for AI? Can you kind of like give us a brief description of a strategy or sort of like an approach?
Yeah. The best, we've been talking about this forever, the IT/OT convergence, right? And the best companies solve that problem first and foremost. So they don't just have kind of an IT go and build a complete, digital twin, like only think about data fields, and they don't understand what the model of the factory should be. And then they don't also have OT, only pick the one or two next use cases that they're after, and then not invest in something that's going to be the scalable architecture. They come together. So first best practice starts with people. We work with a lot of top manufacturers in the world, like Flex and Jabil and Harman, Samsung and BAE. And there are individuals that either themselves sit at the intersection of IT/OT, and they're empowered to lead these divisions, these digitization divisions, or they really bring IT/OT together. So it starts with people, right people in the seat who can understand the IT/OT conversions and think about the model that needs to be built. And then the key part, and this is hard, so tons of empathy for everyone that works on this every day, is you both need a model that scales, but you also need ROI from the beginning. And that's the hardest thing of this, right? Because you can go wrong because, I built the model that scaled, but I'm not getting any ROI yet. Or I'm getting ROI on the first use case, but the technology pieces I picked, my data model, they're not going to scale. I'm going to have to start over next year. And so the magic comes when you sit right in the middle. And that's, again, back why it's like picking the right people, putting them in the seat, enabling them, having a long-term vision. So building a roadmap that is a multi-use case roadmap. Let's say 2 to 3 year roadmap, 5+ use cases. So you're not just, too myopic on just one use case, but you are use case driven at the same time. Like, there are explicit use cases that must bring business ROI to this. For example, things like using AI to better root cause downtimes, right? Or using AI to drive scrap avoidance actions, right? Or using AI to increase quality on our highest revenue products, right? So you would pick these use cases that are really specific. Let's say you pick that quality one. Now, what does your digital twin need to ensure you can optimize quality? Well, it's definitely going to need the test information across these lines. And then as you start figuring out what's causing your defects and leading to repairs or scrap, you're going to need the information, maybe from specific machines that really correlates to that. Do you need every single piece of data in the entire factory, every camera feed from day one? Probably no, but you do need a decent set. And so that could be your first use case in 3 to 5 on your roadmap. And then if I pick this KPI, quality of my top products, and this use case using AI to predict and do predictive quality, okay, what does that mean in terms of what do I need to connect and who's feeding that into this data model that's not just going to be one-off for this use case. It's going to scale to my plants and go across, right? And that's how you build it up. And so when you're done with this thing, you've got good people leading, you've got a 2 to 3 year roadmap, you've got 3 to 5 use cases, not just one, but a small enough number that you can hold them accountable. We need to hit ROI in these use cases. That's how I see the best companies succeeding at this today.
Awesome. No, I kind of like want to take a step back, to talk about this idea of sort of like people, processes, and I think you mentioned the other P, I've forgotten, but I want to kind of like focus on the people that kind of like, whether they are interacting with the mobile phone through voice, entries and things like that. I want to kind of like talk about the reverse of that, where you've got the AI kind of like feeding that information back to the people. I think this kind of like the idea of an AI Copilot is kind of like, using that same digital foundation to sort of like, bring those insights back into the people. Could you speak to me about how you view that, process, or how that, works typically?
Yeah, absolutely. So, I mean, if I could like go from the whole thing a little bit, maybe I can kind of throw ChatGPT on here for just a moment.
Oh, yes, please.
So I could say, hey, ChatGPT, tell me something about the company HiveMQ.
HiveMQ is a company that specializes in developing MQTT-based messaging solutions. MQTT.
So it knows something about HiveMQ already, and I can just talk to it, and it could, and this is, I'm just trying to learn about HiveMQ, but it could co-pilot me on that. But first, it had to get information into its AI, which it did a lot of these general AIs by reading all of the internet. So we all have web pages and other things, and so we fed it. In the factory context, like you said, we were talking about getting all the data into this digital twin and having people talk into their phone, the knowledge in their heads, not in a machine, talking into the phone, uploading manuals, that kind of thing, to put data into a digital twin. Because these general AIs, extremely powerful. They know so much about us already in the world, but they don't know about your factory, right? They don't know you're building a specific model of phone or a pacemaker or plastic pellets or whatever you're doing. And these are the parameters that they know generally, actually a lot about what it means to do plastic extrusion or PCBA manufacturing, but they don't know the specifics of your factory. So that's why that data input matters specifically. But if you combine now these general AIs that already know high level about PCBA manufacturing, plastics manufacturing, semiconductor manufacturing, and now you give them the specifics of your factory. Here's what's happening right now. Here's what happened last week. You put that together. Now the AI can do amazing things, and hopefully folks can see that. So your question, Kudzai, is like, what does it look like to be co-piloted by the AI? It looks like, being able to get outputs directly, or even ask questions and have it give you exactly the information you need when you need it. And one example I gave of that is, so there are use cases, I think, in the factory where, just like we just did, it'll talk to us. And like, let me call out one of those, because I think it's easy to understand for people. Is like, let's say you're doing maintenance and you're the maintenance technician and you've been called out to the line, and a machine's down and you need to fix something. Okay. And the machine knows the error code, and the AI has read the manual and it knows the error code. And so it just pulls up the right thing, and you can talk to it. You say, hey, what do I need to do? And it says, hey, you need to first make sure you click the power, safety, do this. And now you need to pull out the cable and, and it could literally talk you directly through what you need to do, as if there's an expert standing right next to you, saying, do this next, do this next. And I could be the person who just came to the factory 6 months ago, and I don't really know what to do, but I'm being co-piloted by this AI. Now, again, the key to this, that use case is valuable and it is the future. It works because not just that you took these equipment manuals and fed them in, because more than half of the knowledge in the factory is in the sensor data and in the knowledge in people's heads. And so when you've combined the experts in the factory, their knowledge, the machine data, and these other things, that's when it's inside the AI. And now what's so transformative is especially for the young talent that's going on. If it's okay, because I may be taking just a step back. I think most people listening have probably heard this before, but if anyone hasn't, one of the mega challenges in manufacturing is the workforce transition. The fact that it used to be the case that people would stay 20, 30, 40 years in manufacturing and even in one plant. And imagine just how amazing their knowledge is to run that plant at that point. And younger generations, they just don't want to do that. I was in a plant a couple of weeks ago that had like 30, 35-year average tenure of like a third of the workforce. And then the other half has like a 3-year average tenure, and they're leaving at 15 to 20% year over year. So they're never going to get ever to the 30-year average tenure. It's 3-4 years average tenure. By the way, that's how my business, I'm a software business. My people stay 3 to 5 years and they leave. If I depended on people needing to stay 20 years to run my business, we will be dead. It's never going to happen. And this is now happening to every factory in the world, that you cannot count on people staying 10 plus years anymore. So you must find a way to co-pilot and guide these people with only 2, 3, 4 years of experience to do really high quality work. And that is an absolutely critical part where AI fits in, like that maintenance example, like talk to me, tell me what to do when it has this information, can guide people. And the person can say, actually, that's not working. Let me take a picture. Or no, that cable's not here. Oh, okay. Oh, so in a less common scenario that the expert shared with me in the past, the cable's actually on the other side. Oh, you're right. It is there. Thank you. Just like the way that if that expert was next to you all day long, it could have guided you.
Oh yeah, absolutely. I mean, I can kind of like really totally relate with that, because I've got a background in system integration myself. So we used to go into all these different manufacturing factories where, there's always, people who have been there for close to 30, 40 years. Whenever you need assistance with something, electrical issue, a certain piece of equipment, it's always that one person who knows what to say or where to look to find that information. So for me, that was really eye-opening, right? I mean, let's kind of like now dive more into Arch intelligence solutions. So there's 3 intelligence solutions here. Let me know if I'm leaving any one out here, but it's kind of like the information that I got off your website here. I want to talk about your ArchFX platform, and then ArchFX Glow, and your ArchFX Process Insights. So
Yeah.
let's start off with the ArchFX platform. Kind of like give us a breakdown. What is it? What are the features, and how is it really positioned to transform manufacturing operations?
So if I could say first, so our specific company, what we come in is to guide manufacturers from data to insight to action, the entire journey.
Yep.
We like to break it out into the components that people really recognize: platform, Glow, which is global and local operations tools, and process insights, where it's like get all the data, pull it together. The process insights is actually where we invest time to make specific insights in your industry, your process, circuit boards, injection molding. There's a lot of things that are specific to each area of factories. And then our overall application is called Glow, to guide these intelligent actions for people. So I'll say that overall, data to insight to action is when investors like to characterize us, they call us a vertical AI company or a vertical SaaS. In other words, we're vertical specific, we're manufacturing specific, we're only for manufacturing. We're not for agriculture, we're not for power plants, we're not for grocery stores. Like, we're only for manufacturers, and we go data to insight to action end to end. So if you take the first key piece of that, the ArchFX platform, this is the part of our solution where we connect to data sources. Could be coming from an MQTT broker like HiveMQ. That's fantastic when something like that is in place. It could be coming directly from machines that aren't connected to another broker yet, like test equipment with a lot of log files, retrofit sensors that you mentioned. could be coming out of an MES, right? An MES system could have been set up and be itself connected to machines or things. And so our platform is the ability to kind of data mine, and it lives next to a lot of organizations are trying to build these unified namespaces, unified data models, where they've hooked everything together so that they can power any given application stack, their own internal applications and external applications. What we are is we're a third-party AI application that can take you all the way, and we can help accelerate these, with your IT teams, you getting to this unified namespace inside your company. But for the OT guys, we can also make this promise that we can get data no matter where it is. So you don't have to have like a perfect finished project here. If you've got, HiveMQ in place, that's fantastic. If there's a factory where you just have a bunch of test machines and we got to mine logs directly, no problem. We have a fantastic log agent. We do that too, right? And so the platform is not a product really by itself for us. Like we don't sell the platform. So, for then we do have customers that use us as middleware because we have this amazing model and we can help you build this digital twin. And then you can for sure use that to help feed information into other control systems or other AI systems, but it's a means to an end, right? It's data to insights to actions. And the end result of ArchFX is to guide your global and local operations. So Glow is really our unified application, and it has 3 components. It has the KPI sets where you say, what are the goals of my organization? Am I going to push quality? Am I going to push machine utilization? Am I going to push mean time to repair and downtimes, right? Scrap rates. What are the things that are the most important KPIs? Track them in KPI sets with high visibility. And now at the shop floor, I want to use the action manager to guide these actions to people, and I want them to react on time to it. So these are the 3 components: KPI sets, what are my goals? Create guided actions, and then ensure that my operations are reacting to them in real time and making improvements in the factory.
Awesome. Sounds to me kind of like your platform is like the plumbing, right? Kind of like laying that foundation for then building up all these KPIs. So could you maybe, at the risk of getting into detail, could you kind of like talk to us about what that experience looks like for kind of connecting machines? Do you have like a low code platform? Is it automatic discovery? How does that experience look like of onboarding all these different data sources?
Yeah, so the way a lot of manufacturers understand us is that we're both a technology stack and a services group that's like directly there to get the job done. I think that's one of the things that we're known for is like, do we have some embedded no code? We do. We have a great embedded no code platform to help do some of these integrations. But more to the point is like, because we're data to insights to action, manufacturers pick us when they're like, I want to make sure I am using AI and analytics to drive improvements right now. Like I want predictive quality, I want predictive maintenance, I want downtime solved, and I want AI to do that. And over here, I've got some things that I'm going to build in-house, but this application I want to do with Arch, right? That's why people pick us. And then we drive end to end. So yeah, talk about the connectivity layer. How does it look like? It's a combination of a library of pre-existing connectors that we just deploy, and then a no-code platform to quickly integrate things that aren't already in our library or maybe are custom, so they couldn't be in our library. So for example, we do a lot of work in printed circuit board manufacturing, PCBA. And there's a specific process there called surface mount technology. I made a couple examples with it, like the robot that puts the chips down. We have already written more than half of all of the connectors to those equipment, which means we know what sensor data to expect from those ovens and inspection machines and placement robots. And we have a full data model ready for them, right? So we just connect to the source of data, and data, like literally in 10 seconds, I'm not making it up because it's all pre-written. Like we collect IP addresses from the machines or whichever part of the infrastructure is concentrating the data. We click the button, data flows into our platform, into our digital twin model, and into the applications, and you have live dashboards and alerts in 10 seconds, all the stuff that's pre-built. Then you ask, do I want to build something new? Do I want to build a new KPI? Do I want to build a new alert profile? But that's one of the hallmarks of our application, that as it gets better and better over time, because we're pre-building more of these KPIs and more of these insights and mapping it to more and more of existing machinery. And so every time manufacturers turn on Arch, there's more and more that just comes straight out of the box.
Awesome. So maybe to kind of like paint a more sort of like clear picture of adoption for our audience here. So you kind of like talk about this idea of data to insight to actions, and also this, ability to get all of this information in like matter of 10 seconds. But I want you to kind of like describe for us that, implementation roadmap, like from the time you engage a manufacturer up until they start getting the results. How does it look like? What is that time it takes from the time they engage you to time they start getting all of this information?
So every collaboration starts with a pilot, proof of value. And usually we seek to pilot in actually 2 factories or 3 instead of just 1. So we don't pilot in, let's say you have 10 factories, or 5 factories. We're not going to pilot in every factory in the world, but we do like to pilot in more than 1, because it is actually a very fast setup. And what's critical to the pilot is seeing value. And you see value when you have the ability to use AI and analytics on a greater mass of data, right? So if you do a pilot on just like 1 machine in the corner of your factory, it's like, it may or may not help you very much, right? Whereas if you have the data from, let's say, 5 lines in this factory and 5 in that factory, 10 lines, and each line, 1 every 5 to 10 weeks, some big problem happens that we could solve for you. Now, instead of waiting 10 weeks to see 1 cool thing, every single week, you see a major problem we improved, right? So, so it starts with a pilot. It starts with us showing how easily we can connect and show, so we win the trust of our partners to say, yeah, let's use 5 lines or 10 lines instead of just 1 in the pilot. Then we do the ABCDs of our pilot. So A is approval. We always talk to the CISO and the security group, make sure they know what we're doing. They can see we're going to set up a secure cloud environment for these applications. Their data is not going to be used to, pass to OpenAI or some third-party model. It's all going to be secured. It's all going to be kept private to them. So they say, looks good. We want to see it. That's A. We move to B, which is broker. So we look for MQTT brokers. We get our brokers in place to just move the data where it needs to get. Then it's C, which is connectors. So now we're looking at the specific, all the endpoints of the data that's going to flow in. Machines, MESs, people using the mobile phone, for example. Now all the data is flowing. And, you ask the question, how long does this take? Approvals can take from 1 week to months, depending on what your company's like and their cybersecurity. However long it takes, we do it. Hopefully it takes a week, but it has taken months. Brokers go very fast. That's like work with IT, virtual machine, click these things together. That's a week, 2 weeks, right? Connectors, if it's all pre-written, that's the 10-second magic. If, on the other hand, we're going to write some new adapters to different data sources and we're going to model them, that could take a couple weeks too, right? So, we might be then through setup in a really fast pilot in 2 weeks. A long one with a lot of approval and some new integrations could take a month or 2 to do some setup, right? And then now we're actually ready to run the AI and show the demo. And we're ideally going to do, let's say, 4 to 8 weeks. If it's a more complex one, maybe 8 to 12 weeks of an active period where the data is flowing into some of these alerts with guided action. So, we connected these circuit board lines, the data is flowing. We're seeing when the robot is dropping apart, which is, creating scrap. And if it's like dropping 3 in a row, an alert is coming to the person and it's saying, hey, you need to specifically check this, robot head 2, or you need to check the material, reel number 3 and see if the components are properly seated because you're getting scrap. A person says, okay, they go over, they check it, and they go, oh, that is a problem, right? They fix it. And our system says, oh, 1 action was completed. and we created some value. And through the pilot, we keep trying to say how many successful actions were completed that created value, so that by the end of 8 weeks, 12 weeks of using the software, hopefully the organization has already seen a ton of value and realizes, this is great. I want to do this on more factories, more lines, more data set. And then now we're post-pilot, and now we're going to work together on that use case roadmap over time.
Yeah. So that pilot phase, does that also include the time required to train the AI models, or do they even need the training? Can you speak to us about the training the actual AI model itself?
Yeah, that's a great question. Yeah, I didn't mention the word training at all. Yeah. So this is a good one to demystify for folks, because when you're building a new AI model, so machine learning, training is this really critical phase, right? So if for the first, if you're we're not a company that does vibration sensors and listens, but that's a classic use case. So let's say you're working with a company that's going to put vibration sensors on your pump, and then they're going to listen to it, do a deep learning, and train a model. If they're training for the first time, they might need 6 months, 12 months of data. If they've already trained a model and they're just tweaking it to your specific pump, maybe they need a week or two of data. But what if they're not training at all because they've exactly seen your pump before? They're just going to run it. Okay, they don't need any training. I've seen exactly this pump, exactly these vibration sensors. I don't need any training or tuning of the algorithm. It's just going to run. So a lot of the things that we do are actually in that third category, because we've already been in other customers on similar types of manufacturing, and we already know when to fire alerts. And so there's no training period, so to speak. But what's one of the things that we do training on today? So I mentioned that we're using AI to figure out downtime labeling, right? To automatically figure out downtime labeling. And this is one we're actually using generative AI for. And so we use the machine data, and we use the observations of the operators of what are you seeing? Yep. And sometimes it does also just start working right out of the box, because, we have a lot of good sensor data. Imagine you are the AI, and our system grabs the sensor data and the person, and it says, hey, this line's down right now. And the person said they took a picture, there's a red light over the oven, and we also have an error code from the oven. And you're, okay, I know exactly why it's down. It's for this reason. I don't need lots of training. It's we make a description of each problem, and we let the AI say, can you figure out what's wrong with it, right? Now, on the flip side, if this algorithm is starting to run and there's not very much information here, and hey, what did I do last time the same error happened? Nothing yet, because we don't have any history. And this machine doesn't even have error codes. So the only thing I can tell you is that it stopped running 5 minutes ago, and the person said, it's not the printer. Okay, I don't have enough information. I can't guess why it's down. I just know it's not the printer, and it's been down for 5 minutes. That's all I know. And so in these kinds of situations, there is a couple weeks time of starting to collect more notes from operators, more machine data, know what happened in the past, so that this algorithm can make a guess, even if just hey, it's down for 3 minutes. Well, when it was down for 3 minutes in the past, it was always this. So even if I only have a little bit of information, I can make a really good prediction from past data. So that's the delta. When you have tons of rich information, you don't need much training for these AIs to find the right answer. When you have little information, you need more training and pattern matching, and it could still be wrong, but the AI can, get it right from enough history. So that's why I think now it's more of a nuanced answer than it used to be. Because before ChatGPT, it was AI means machine learning. Everyone's always building a model, and it typically means 3 to 6 months of sensor data. Now, with these pre-trained amazing AIs, it has more to do with how rich is the information you give it. So therefore, does it need the history, or does it not need history at all to just out of the box start giving you great insights?
Awesome. It makes a lot of sense. So now, I'd like us to move on to some. I know you've kind of given us a few examples, but let's kind of dive into a few practical use cases, if you may have a few to share, where you kind of real world examples where your systems were, implemented and they had this significant impact, and also if perhaps you've got some measurable results that you could share with us?
Sure. So I'll start with some of the results that hit fast and hard from the beginning, and then maybe I'll give a couple of the examples that come after you've been using it longer. So, for example, in an automotive manufacturer, we set up our system on these circuit board assembly lines, making motherboards for automotive parts. And one of the questions to our analytics AI system was, are these lines running as fast as they could, right? Are they getting all the throughput? Because this manufacturer had some new significant orders and demand coming in, and they were set up to spend on order like $21 million for new CapEx, new hardware, new lines to meet demand. But they have an existing lines. They have a lot of lines. And the question is, how is their utilization? How are they doing, right? So KPI, utilization and throughput, we take a look, and we have an algorithm that automatically calculates golden cycle. Like, what is possible if you could move it as fast as possible? And so we determine something on order 30%. Like these lines have a lot left in theory. You're never going to get 100%. That's not actually practical. But if you could get even from 30 to 40 to 50% of their theoretical throughput, it's worth a lot. So then the question for our analytics after we connected the machine was, can you identify the root cause? Like, why are these lines so bottlenecked? And then the next question is that solvable or not, right? And because sometimes, the root cause is, well, let me go with the root cause of this one. So for many of these lines, the root cause was really long test times. So a lot of the equipment in these lines could go faster, but there was a giant bottleneck at test. You picture like you're driving down the road in your car, there's a traffic jam. You're like, who started this thing? Like, and it's somewhere in the future, there was a crash or someone just swerved and it created this whole buildup, right? So in this case, the buildup was from test. And the next question is that solvable? Because maybe it's like the customer told us we had to test every product for 20 hours, end of story. Well, could you have bought more test equipment? Well, we already did order them, but they don't arrive for 3 months. So we're just stuck, right? Okay, nothing we can do, right? But in this case, we identified severe bottlenecks in test, and our system automatically finds the specific test programs. Like, these are the ones that are taking so long. And if this test program took half the time, you get back 15%, throughput through the line. And when we were able to surface those analytics, the root causes that we found with analytics and AI to the experts in the company who were across the ocean in a different place, they looked at that and they said, we don't have to be testing that long. Like it's absolutely possible to have proper test and reduce that. They reduced it, lines started running. There were some other lines where they said, we do have to be testing that long, but we had wanted there to be a buffering system in place to compensate for that. So the whole line could run, and then test could run more in parallel. And they realized that some of the buffers weren't properly working, or in one case, there was a buffer even missing, right? So this was an example of analytics AI finding the root cause of a bottleneck, being able to resolve many of the bottlenecks, and we unlocked enough speed that they were able to save $7 million off of this new CapEx purchasing they were going to do, right? Reduce from 21 to 14 million and fulfill the customer's orders with confidence. So that's an example of kind of an upfront, you set up the system really quickly. How's it running right now? What's the health? Is there any big things that I can fix immediately?
Yeah, absolutely. That's quite some significant, gains. I mean, if you could get like 30% more utilization, that's significant for a lot of manufacturers.
So I'll give maybe I can go one more example. So we had a smaller medium-sized manufacturer who also an upfront value. They set up our system, and we start automatically figuring out the downtimes of the line, right? And this huge category of downtime is for validation. Like every single time that they're doing a changeover, which means they're running one product A, now they're going to do product B, they're doing this huge downtime right after the first article. So the first product goes through. And we see that the effect of this, and it's like extremely huge on the productivity. And I asked the question, like, why are you doing this? And they said, well, we've done that in this particular line's plants for a long time because in the past, a customer required us. Are you still required to do it? No, we're not required. We just thought it was a best practice, right? And we said, well, we have the data from tests, so we can see in real time if you're having a quality issue. there's no reason you shouldn't be able to just keep flowing the line and now depend on the real-time quality measurements to be able to stop quickly if that first article was actually had a yield problem. And this is again something that, like, once you have the insight, you're like, oh, that seems pretty clear. Yeah, let's stop doing these major stops for validating, because we can digitally use the test data, say it's okay, and just run. There was a particular line, sounds like an unreal number, but actually made a 90% increase in OEE because there were so many changeovers happening and these validation stops were so long that by removing these and using technology, using digital technology to run the tests, give the confidence and high yield, which is working great. It was just an enormous increase in OEE on these jobs. So that was another, that's definitely not the typical result is that big, but these are two examples of, like, some of the, not every line in your enterprise, obviously, but some of the lines you're going to find these quick upfront problems and solve them. And then what's going to happen over time is these problems get reintroduced. Like, you could have a line that's running perfectly today, but maybe right now you're running it with a bunch of these stops because the customer requires it or the job requires it. Yeah. And you'll do that in the future. You'll shift to a new customer. It's no longer required, but you keep this old practice in place. And so by having this visibility, finding root causes of problems, you speed up. Here are places to improve efficiency. Here are places to improve efficiency, right?
Awesome stuff. Yeah, to kind of like close this conversation today, I've got two questions for you. So first of all, I mean, there may be some manufacturing leaders who still sitting on the fence as far as adopting AI for enhancing their sort of like workflow efficiency, and maybe also some who are in that very first phase of adoption. What would you have kind of like as key considerations and recommendations in how they should get started, and kind of like also, can you speak to us about where do you see all of this going? What to you is kind of like the future of AI in manufacturing? If you could kind of like paint a picture for us of how you see, especially maybe your systems in the next few years.
Yeah. So final two thoughts. So people sitting on the fence should absolutely dive in. I'm not the kind of person that wants to scare people, but I do think in 20 years, possibly even in 10, a factory that uses no AI is a factory that no longer exists. Like, it is this powerful for the efficiency of a factory that if you're not using it at all, you live on your cost equation, right? It can threaten the viability of your company. Now, on the flip side, the barriers to adopt it have never been lower, and there's a lot of great people to guide it. So, back to that, find people inside your organization that sit at the intersection of IT, OT, and enable them. They probably would love to have this opening in this job. Often it's people at the manager, director level. If you have C-level and VP level people who understand this and want to dive in, that is fantastic. You should do it. But if you don't have that, don't take that as a reason not to dive in. That's more common. It's more common you have great C-levels and VPs who are starting to understand the technology. They understand the business priorities. Empower someone at the director level, the manager level, to lead and guide them with KPIs from the top, and have them, go do an effort of picking some partners, having a couple internal resources, and getting started, right? And I think you'll be extremely glad you did. In terms of the last question of like, where is it going in the future? Go back to that statement of the changing workforce and the fact that too many manufacturers are still living in the past. This idea that people would stay 20, 30, 40 years at their company and just become I know everything about your company and do that. Those people are amazing. Every manufacturer needs to value and keep those people as long as they can, and accept that the future generations are never going to do that. And so they need to enable a new way of working. They need to enable a new way of coaching or co-piloting for this next generation to do amazing work in their companies. And these AIs can do 20%, 30% of the work required to run a factory alongside people in a way that the people want more. not less. Like they want these systems. They want to work alongside them. And this is fantastic news for everybody if it can be done well. For the people coming into the job, one of the top complaints is it's so hard to work in a factory. Nobody's giving me guidance. I got burned out and I left. You transform it with technology. I like working at this company. I know what to do. I get to use an interface I'm familiar with. This is fun. I like technology again. And for the people running the company, I have a path to a future-proof company that doesn't lose expert knowledge with this AI that I can hire that's never going to leave. And it's going to do these things at like probably a fifth of the cost of what it used to cost. That's amazing, right? So there's a huge win-win here that requires a little bit of future investment, empowering some people probably in the middle of the organization. And it's coming faster than a lot of people think.
Awesome stuff. So, yep, that brings us to the end of this session here. So we'll provide links to your website and all the material that we made reference to here today. Do you perhaps have any last words for our audience before we close the session?
I've said enough. Just thanks for having me, Kudzai. It's been an absolute pleasure. What you guys are doing at HiveMQ is extremely important. Putting these building blocks together, really scalable technology. So great to be here with you and big fans of your work.
Awesome. Thank you so much, Andrew. Really appreciate it.
Yeah.